What's up, everybody? In this problem, they are asking us to say if the probability of A plus the probability of B is greater than the probability of A union B, if this is true or not. So how do you solve problems like these? The way for you to solve problems like these is to know some common properties that happen if A and B are mutually exclusive or A and B are independent. There's no single way around this, so you need to memorize some of these properties. And as long as you keep doing more and more of these problems, they start to repeat themselves a bit. In the beginning, it's very confusing, but then you start to get around of it. So let's begin. The first way for you to solve this problem is by stating like what's the condition that happens when the probability of A union B when both A and B are independent. So when this happens, we have the following expression. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A and B. And we do this because we are not double counting. What this means is that we have the probability of A. Let me get this in a diagram. We have A here and we have B here. And A and B is this part here. So what we are saying is that the probability of A, so it's this guy, and the probability of B is this guy, so one plus the other, minus the intersection, because otherwise we would be double counting. So since this is the case, when these are independent, there is an intersection. In the problem, what they are telling us is that the probability of A and B is greater than the probability of A union B. This is true. Why is this true? This is true because they are saying that these two, this is greater than the probability of A union B. And this is true because the probability of A union B, it's this one minus this guy here. So it's this element minus this here. So when they are saying to us that the probability of A plus B is greater than this one, because they are not subtracting the other one, otherwise they would be equal. So this one is greater than this one. This is true. What about the following problem? They are now telling us that the probability of A given B is equal to the probability of A given B complement. If this is the case, they are telling us that A and B are independent. Again, the way for us to solve these problems is knowing the properties. So the probability of A given B is the same as having the probability of A and B over the probability of B. And this other guy, it's the same thing, but with a separate element here. So let me get this in a different color. So this one is equal to the probability of A and B complement over the probability of B complement. So this is what we have to start to work. So in order to solve this problem, what we are going to do now here is, let me clear out this one so we have more room. So for us to solve this problem, let me get this one here. So the way for us to solve this problem is by now decomposing the expression and continuing our problem. So what we are going to do here now is some cross multiplication. This guy goes over here and this guy goes over here. So we have the probability of B complement times the probability of A and B is equal to the probability of A B complement times the probability of B. So what is it that we can do now? When you have an expression like this, you can further decompose it as follows. So we are said that it's B complement. What this means is B doesn't enter the expression. So what we do in this case, just change the color. This is the same as having the probability of A minus the probability of A and B. And all this is multiplied by the probability of B. We have done nothing different. We just changed this one to this one. And on this side, we're going to do the same thing. The probability of B complement is the same as having 1 minus the probability of B times the probability of A and B. So we're going to use the distribution element here, and we're going to get, change the colors here again. We're going to get the probability of A and B. It's just this one times this one, it's 1, minus the probability of A and B times the probability of B. So all we did was we got this one to this side and this one to this side. That's it. And we got the probability of A and B minus the probability of A and B times the probability of B. And that is equal to, change colors again. So now we're going to do the same, this one to this one and this one to this one. So we get the probability of A times the probability of B minus the probability of B times the probability of A and B. So we are further decomposing the expression by knowing a couple of expressions. Now look at this, let's look at what we have to work with. We have this one here. Notice that is exact the same thing as what we have here. So we can remove both these ones. And you notice that now you have, let me get this to the bottom part. It's a probability of A and B is equal to this one, get it here, get on a different color, the probability of A times the probability of B, which is true because when the probability of A and B and both A and B are independent, this happens. So this is true as well.